So starting our new unit, and it's all about 3D shapes. But first we're going to talk about polyhedrons. Now, polyhedrons are basically made up of lines and faces and edges, all that kind of stuff. So it's anything that you could kind of draw, like this box of Kleenexes is a polyhedron, a special kind, got a cube, right? So each polyhedron has faces, which would be like the flat part of the box. Then we have edges, it's kind of like the lines where the two faces come together. And then we have a vertex or vertices, and that's the point where the lines come together. So if I were to draw a box here on the screen so you guys could see it, those are all the edges that I'm drawing, and the points where they meet are the vertices, and then the planes are the flat pieces. So if you want to draw a cube, you can draw the faces with lines and connect them. Now, this formula here is very important. It's called Euler's formula. I know it looks like Euler, but it's actually pronounced Euler's. So Euler's formula says the faces plus the vertices equals the edges plus 2. So maybe, for example, like with this one, you could count up how many faces that you have. So how many sides do we have to like a cube? 6. And then the vertices would be like the points where they meet. So how many of those do we have? 8. There's 4 on the top and 4 on the bottom. So 6 plus 8 is 14. Now edges are how many lines that make this up. So notice I drew 4 lines, then 4 lines again to make the front and back faces, and then connected them with 4 lines. So 4 plus 4 plus 4 is, and then plus 2 is 14. So 14 faces and vertices, 12 edges plus 2 makes 14 as well. So this works for all polyhedrons that you have. The faces plus the vertices equals the edges plus 2. This is a formula you need to know that will not be given to you, so make sure you put a little star by it in your notes. All right, so let's talk about our 5 types of polyhedrons. You do not have to draw these pictures, of course. That might be hard to draw, but go ahead and write down these 5 types. They are regular polyhedrons. Now, regular means that they have all the same angles and all the same side lengths. So they're equal angular, equilateral, or those words from our last unit. The number in parentheses is how many faces that it has. What would I what? Oh, well, my favorite one of these is the icosahedron, the last one. Have y'all ever seen the Moravian stars? You know, the big stars at Christmas? The base of that is an icosahedron. There you go. Yep. So icosahedrons are actually really popular because they're 12 equilateral triangles that you kind of put together to make into that 3D shape. And then when you add points on them, that becomes like your Moravian star that you see at Christmas time. Dodecahedron is basically like your soccer ball pattern, right? It's got pentagon shapes. Octahedron, it's got 8 triangles, so 8 equilateral triangles. A hexahedron, or cube, that's our Kleenex box. And then the first one is a tetrahedron, which is 4 equilateral triangles. So the base is an equilateral triangle, and then there's triangles connected to the 3 sides. So there's 4 that kind of come up. It's more like a pyramid look. So there's one on the back. So you can see like the back side is a triangle, then this side, front and left, and then the bottom is a triangle. But remember, these are regular polyhedrons, so they're made up of the equilateral shapes. So there are equilateral triangles in the tetrahedron, octahedron, and icosahedron. And then in the hexahedron, it's squares. And then the dodecahedron, it's a regular pentagon. So they have all equal sides, all equal angles. These are ones you should kind of like recognize, but you don't have to know a whole lot about them. Just recognize kind of what they look like, recognize their names. They're also called the Platonic solids. Named after Plato, Platonic solids. So he did a lot of research and things with those as well. All right, so let's use our Euler's formula to find the missing information. You can just use Euler's formula and then write down your 3 problems. And we'll see if we can solve for the missing piece that's there. Is that right? How about your day so far? Yeah? I'm glad. Oh. Yes, I agree. Yes. I would shut my door so my dog doesn't come in and look me in the face. No, I'd be like, forget you. All right, so let's use our Euler's formula. What does Euler's formula say? Good. So plug in everything you know, solve for what you don't know. We don't know the face. We know the vertices is 9. We know the edges is 15. And we add 2. That's right. And that's it. That's all you got to do. Plug it into the formula. Solve for what you need to solve for. So 15 and 2 makes 17. Minus the 9. Faces is 8. So we'll try the next one. So we would say 8. Good. 8 plus 12 is 20 equals E plus 2 minus 2. E is 18. So just plug into the formula. Find out what you need. Some of you probably don't even need to show work for this, and you don't have to if you don't want to, but memorize the formula. Now, this one's a little bit different because it doesn't give us that information, but it does tell us it's a polyhedron with 8 triangular faces. So we need to think about what would that look like to help us figure out how many edges it has. It is. If we go back to some of these pictures, it would be an octahedron. This one has 8 triangular faces, right? Now we want to figure out how many edges that we have. What do our edges look like? They're the lines that connect. So, well, let's figure it out. Let's see. How many triangles do we have on top here? 4. So if we were to connect those 4, how many lines would we have? Well, you'd have 4, and then to connect the bases, you have 4 more lines, right? So there's 4 on the top, 4 in the middle. How many on the bottom? Also 4. So what's 4 plus 4 plus 4? 12. So there should be 12 edges. Now, you can check in your formula to see if that works, right? Oh, we know that there are 8 faces. So faces plus vertices equals edges plus 2. So let's figure out how many vertices does it have. Now, vertices are like our points, right? So how many points do we have in this picture? Well, there's 1 at the top, 1 at the bottom. How many around the middle? 4, because it's kind of like 2 pyramids that are stacked together, so we have 6. Is 8 plus 6 the same as 12 plus 2? Yes, it is. Both of those sides would make 14. So sometimes you have to visualize it. What would it visualize like? What would it look like based on that description? And then you could figure out, okay, well, we must have 12 edges to connect 8 triangular faces together. Now, if you do get confused on this, because this is just homework, Jackson, what are you doing? Let's not take pictures unless you ask permission first. And you need to just write this down instead. But if you get confused, you can type in the description into Google and it will come up with a picture of it. So that way you can kind of look at it and just count. So that's just homework. On tests or quizzes, you can't Google to look at the picture, but for this you can. All right, last thing you need to write down is just those sentences up at the top. You don't have to draw these pictures. And the next few examples that we do, you don't have to draw those down either. I think you can get it just from this description. Faces, vertices, and edges, yes. Mm-hmm. Yeah. Mm-hmm. It does based on what kind of shape it is. Like you might see some homework problems that say it has a different kind of base and certain kind of shape. So you just kind of got to put it together. Like what shape would it make? So there are 2 ways to think about cross-section. The cross-section is the intersection of a solid and a plane, or you could think about it as a very thin slice of the solid. So imagine we have our Kleenex box. Now, if I wanted to do the cross-section of it, maybe I want to cut it like horizontally or whatever, vertically, however you want to think about it. You can cut it, kind of rip them apart, and make a stamp of it, and what would that stamp look like? Or you could think about, what if I cut out a very thin slice? What would that slice look like? So part A here is kind of like the same kind of picture. If you were to cut that out, what 2-dimensional shape would it make if you were to stamp it? It would make a square, right? And how do we know it's a square? Because it looks like a rectangular prism, which we're talking about. So imagine that you cut it and it's kind of parallel to that base. It will be the same base. So what do you think the shape would look like in part B? A triangle. The cross section. So imagine if you like cut it and then made a stamp of it. What 2-dimensional stamp would it make? Depends on how you cut it. Now with this shape, it looks like that plane is cutting like kind of parallel to the base. So if it's parallel to the base, it'll make that same shape. So that one will be a triangle and that one would be a square. All right, these next 2 problems you guys don't have to write down, but we're going to look at what would happen. Now, what happens if your cross section is more slanted like that one is? Which shape would it make? Now, when you also do a cross section, even though you cut it this way, like diagonally, imagine if I turned the paper to where it was facing you. What shape would it make? So what do you think? A, B, C, or D? C is correct because we turn it back towards you to see what that shape would look like. All right, then this one we're talking about rotating a shape. So when you rotate a shape, what would create this 3-dimensional shape? So when you rotate it, you spin it around. So which one would make that shape? A, B, C, or D? C is correct. Some people have said A before, but that would only make the top part of that kind of shape. So to have the top and bottom more pointed, it would have to be C. Now, there is a website, and I was going to show you guys. It's over here. Hopefully it still works. Let me click it and see if it does. But this is kind of a fun little website. Okay, I put my pen down. I guess I didn't move that. This is a fun little website where you can go in and like pick out what kind of shape that you want, and it will rotate it around to kind of look at what that shape is. So if you click go and graph, come on, rotate. Maybe I got to spin it. Maybe I can't spin it with this. Where's the, oh, there it is. Will it rotate? All right, well, it used to work, y'all. I think I have to, maybe I hit graph. Well, I didn't have to before. Well, let me just throw in something. Let's see if that'll work. Y'all may be right. I could be wrong. Okay, or it won't do anything. Well, reset. Well, it used to drag and rotate, and obviously it stinks, so never mind. Don't worry about that. Pretend like you didn't see it. All right, so that's it about polyhedrons. So now let's talk about prisms. There are two types of prisms that we're going to focus on, a rectangular prism and a triangular prism. But go ahead and write down all of that information. We're talking about prisms and cylinders today. We're going to talk about pyramids and cones tomorrow. Yeah, if you don't want to write that down, you don't have to. Or you can add tomorrow's notes to this. Either way. If y'all see Abby, tell her happy birthday. Today's her birthday. Yep. That's right. She hopes she's getting her license today. She was so funny. She was like, I might get my license. Sure do fine. Yeah, go ahead and draw the shapes best you can. If you can't draw them, it's okay, but if you can, it might be helpful. You know, I haven't been too good at it either, but if you draw the bases and then just connect them, so basically draw two rectangles and then connect them, or draw two triangles and then connect them, that's like the easiest thing to do. They don't have to be perfect. So while you guys are finishing up drawing these, I'm going to go ahead and talk about what these things are. So lateral area is the sum of the area of the faces. So when I think about lateral area, I think about painting a room. When you go in to like paint a room, what do you usually paint? The walls. You don't paint the ceiling or the floor, right? Not typically. So lateral area is like you're painting the walls. Surface area is like you're creating a movie theater room where you also want to paint the ceiling and the floors. Okay? So surface area is the lateral area plus the area of the bases. So lateral area is just around, and surface area is all the way around and the top and bottom. So with a prism, it is a polyhedron with two congruent faces, and those faces are called bases, but also the faces are parallel to each other. So in a rectangular prism, I usually just pick out the top and the bottom because it really doesn't matter. You could flip the figure and you could have different parts, but when you see a rectangular prism, consider the top and bottom to be the faces. Okay? When you see a triangular prism, they need to be congruent faces. So the only things that are congruent are the two triangles, because between them, if you think about it, connected with them are three rectangles, right? So the triangles are the bases. So lateral area, the formula for it is the perimeter of the base times the height. That's going to help you figure out where you're going to be painting the walls and how much paint you need. So if you're ever trying to paint a room, all you have to do is find the perimeter and times it by the height, and you know how much paint to get. Surface area is the lateral area, see the pH, plus 2b, where b is the area of the base. Then volume is BH, where B is the area of the base times the height. Now, when you have a box, normally you're going to do length times width times height, right? To find the volume. B is the same thing. The length times the width is the area of the bottom, and then the height is the overall height from base to base. All right, so let's do some examples. You'll have to draw some pictures, but I have faith in your picture drawing abilities. I have faith. So there you go. There's another rectangular prism. This is number 1. We're going to do 3 of these, and then we'll do 2 cylinders. So 3 prisms. And we're going to find all 3 things. Now make sure you put those measurements in the right spot. Something else that I like to do is I like to shade in my base. That way I know where my base is. So I'm just going to shade it in with red. This is the base, right? This is the bottom that it sits on. That way if you kind of shade it in, you know kind of what numbers you're looking at. So what numbers are on my base? 8 and 5. So the first thing we want to do is find P, which is the perimeter of my base. So that's when you add up all the sides, right? So my sides are 8 and 5, and then there's another 8 and 5. Then we times it by H, which is the overall height. Now H is the height from base to base. So rectangle to rectangle is how much? 3. So this part is H. So you might want to write that beside that number so that way you know what's the overall height. Right, so perimeter is all the sides added together. So this side would be 5 and this side would be 8. So 5 and 8 and 5 and 8. Got to add up all 4 sides. 26 times 3. And then multiply that out. So grab those calculators. What's 26 times 3? 78. Now the other thing we need is to put some units on here. So this is in inches squared because it's talking about area. So square inches or inches squared. Good. Now we do surface area. Surface area formula is pH plus 2b. Now the good news is we already know pH, right? pH was your lateral area, which was 78. It's just the 78. The squared is only on the units. So it's just the 78. Plus 2 times B. Now this capital B stands for area of the base. So what shape is our base? It's the bottom. It's a rectangle. How do you find the area of a rectangle? Yep, 8 times 5, so it's 40. To find area of a rectangle, you multiply length times width. So area of rectangle. And this could be of a square as well. It's length times width. So what's 2 times 40? 80. So 78 plus 80 is, and then units with it? Good. So there's my surface area and my lateral area. Yep, and we're also going to go ahead and find the volume. So the volume is BH, area of the base times the height. So we already know the area of the base is what? 40. If we look back at this formula right here, it also gives it to us. The B was 40. So we could just plug that in. 40 times 3 is 120. And now we need units on this. Inches cubed now because it is volume. Good. You may notice that volume is typically smaller than surface area. The numbers are different measurements, so they will be a little bit smaller. So the difference between surface area and volume is we're taking paint and filling up this room. You're going to dump the paint cans in the room until you fill it up. So that's our difference between volume and surface area. Surface area, we're painting the walls and ceiling. Volume, we're throwing the paint cans in. How many paint cans will fit inside if we dump them in like liquid? All right, let's look at problem number 2. Now, I've got a triangular prism here. It sure can. Sorry, I didn't realize you were still writing. Just draw a right triangle, then draw another one below it, and connect them. So, it's perimeter of the base times the height. So since the base was that rectangle, you add up all 4 sides. See, it's PH, perimeter of the base times the height. Yeah, so this one is a right triangle. Yeah, so we got a right angle there. Yeah. Now, when we look at the base of this one, the base is the triangle, 8 and 15. Good, so I'm just going to shade it. It's the same formula. So even if it's a triangular prism or a rectangular prism, the formula stays the same. The lateral area is pH. So P is the perimeter of the base. Now, our base is a triangle. Triangle has how many sides? We're going to have to use Pythagorean theorem because we don't know this length right here. So you got to set up your Pythagorean theorem. Since our missing length is across from the right angle, that is our hypotenuse. Okay, good job, but we're going to go a little slower. Okay, so we have to do Pythagorean theorem because we only know 2 sides of this, right? We have to have a third side to do the perimeter. So what kind of triangle is it? And what can you use on all right triangles? Pythagorean theorem. So we can set up our 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. You need to find the perimeter of the base. You need all 3 sides. So the square root of 289 is 17. So our missing side here is 17. There are a lot of probably setting up Pythagorean theorem in this unit, especially if you're missing a side, but you're going to see a lot more right triangles. So the perimeter of our base is 8 plus 15 plus 17. And what is the height of our prism? It is 8. No, it's not a rectangle. So we're adding up. What does perimeter mean? You add up all the sides, right? So in this case, we only got 3 sides, and we're going to add up those 3. All right, so grab your calculators. 8 plus 15 plus 17 is 40. And then times 8. Okay, then it's 320. And units on it? Meters squared this time, yeah. So close. Now, surface area, the same as before. It's lateral area, or pH, plus 2b. pH plus 2b. Well, we already know pH is 320 plus 2 times something. Now, what does B stand for? The area of the base. Well, what shape is our base? A triangle. So now we need to figure out what's the formula for area of a triangle. Good. 1/2 the base times the height is the area of the triangle. Now, when you look at a right triangle, the base and the height will be the legs that make the right angle, because you need to kind of turn it and set it up. So when you look at a right triangle, your base and your height are the 2 legs. So what were the legs in my right triangle? 8 and 15. So it's 1/2 times 8 times 15. That would go in that spot for B, because it's area of the base. Yes. And I'm just going to kind of, write it out again. So if the area of the base, if we found that, we would get 60, because 1/2 times 8 times 5 is 60, and 2 times 60 is, so 320 plus 120 is 440 what? Meters squared, because we're talking about area. So the last thing we need to find is our volume. Volume is capital B times H. Well, we already know capital B, right? We found it right here. Capital B was 60 times the height of our prism, which is 8. Yes. Because capital B stands for the area of the base. So if our base is a triangle, the area of that triangle was 60. And then our overall height of our prism is 8. So what's 60 times 8? 480 what? Meters cubed. Good. Anytime we talk about volume, we put cube on our units. All right, so we are going to do one more of these, and then we'll talk about cylinders real quickly. Oh, whoops. There we go. Well, it's all right. They are drawn for you on the homework, so you don't have to draw them yourselves. It does look like kind of a soccer goal from the side. Now, remember, your height of your prism is the distance from base to base. So what number represents the height of my prism? What did you say down for prisms? Let's go back real quick. I know some of you are still drawing that, but I'm going to go back. The prism has 2 congruent faces. Those are your bases. What is congruent in a triangular prism? The triangles are the bases. So make yourself a note. Triangles are bases. If you consider this rectangle to be your base, you are wrong, and you will get the whole problem wrong. So when you see a triangular prism, the triangles are the bases. And then you can also say distance from triangle to triangle is the height. So H, in our case, is 50. And this little triangle here is your base. So when you see triangular prisms, the triangles are the bases. Now, good news about this base, it looks the exact same as the triangle that we just did, right? The legs are 8 and 15, so what does that mean the hypotenuse is? 17. You'll see a lot of familiar ones and similar ones, so if you memorize it, you can go ahead and do that. Exactly. So LA is pH, perimeter of the base times the height. So the perimeter, add up all three sides again, 40. And then times it by the height, which is 50. So 40 times 50 is 2,000. 2,000 what? Feet squared. Good. So a lot of times, again, you will see similar numbers. So once you do Pythagorean theorem once, look back. You don't have to do it again. Surface area is pH plus 2b. Now, pH we already know is 2,000 plus 2 times. Now, b we also already know because it's the same numbers from the last problem, right? 60. What some people like to do too, and if you want to do this, that's fine. I've seen people do this before, is they put to the side what P is. So they'll say, well, P equals 8 plus 15 plus 17, and that's 40. And then capital B is 1/2 base times height. 1/2 8 times 15, which is 60. So if you want to write those to the side and then just plug them into the formula, you can do that as well. Yes. All right, so what's 2 times 60? 120. And good. 2,120 feet squared would be our surface area. So last thing we need is our volume, which is BH. Well, we already know B is and H is, and that makes 3,000 feet cubed. So a key thing to remember when you see a triangular prism, the triangles are the bases. When you see a triangular prism, the triangles are the bases. All right, so that's enough about prisms. You have, I think, 3 of these to do on your homework. No, there's actually 4, where you find lateral area, surface area, and volume. So we need to talk about one more thing still, though, before we get to that homework, and that is cylinders. Cylinders are like cans of food or whatever you want to call them. Let's see if I move this picture over. Can never escape pie. But actually, cylinders are way easier than prisms, especially if you leave it in terms of pi. Yes, we can, and you should, to make your math even easier. Leave it in terms of pi. Yes. It's still the same, you just use the rectangles, use the bottom. Like, wherever you see a picture of a rectangular prism, use the bottom as the base. But yeah, for triangular prisms, you have to use the triangles. But for rectangular prisms, you can actually move it around and look at different things, but the base, the bottom, is always best. Now, if you notice in here, we have different formulas, different letters and things. What do you think R stands for? Radius. And it's the radius of the circle wherever your circle is. So you can either look at the top or bottom. The radius will be the same. And h is the height. Now, you don't have to write this part down, but I will show it to you. The lateral area of a prism is pH, right? P is the perimeter of the base. Well, what if your base is a circle? You can't do perimeter. You have to do circumference. What's the formula for circumference? Take your finger around the jar. Circumference equals. If you replace that with 2 pi r, ta-da! That's the exact same formula. So a cylinder is a prism with circular bases. Notice this is LA, it's the same, and this is 2 times the area of the base. Well, if area is a circle, area of a circle equals area of a circle. Oh my gosh, y'all, area of a circle. Pi r squared. Good. So if I replace this with pi r squared and my perimeter with circumference, so circumference times the height plus twice the area, ta-da, same formula. And volume is area of the base times the height. Well, if the area is a circle, pi r squared h. So these are the same formulas as a prism. We just replace all the p's with 2 pi r and all the b's with pi r squared. All right, so let's do 2 examples, and then I'll let you guys get to work. So draw number 4, or if you want to, if you don't really want to draw it, you could write down the 2 measurements that are there and what they are. I mean, it's telling you r is 3. What is 6? That's the height. That's h. It's fine. It doesn't have to. But you see cylinders around everywhere, you know, like little cans, cylinders. There you go. Now, again, leave your answers in terms of pi, and that's going to be easiest. So lateral area is 2 pi r h. Well, all you have to do is really plug in for r and h, right? R is, h is. So it's 2 pi 3 6. You can multiply those 3 numbers together and leave it in terms of pi. So what's 2 times 3 times 6? 36. 2 times 3 is 6, times 6 again is 36 pi. Just leave it in terms of pi, multiply all the numbers, and tack on a pi. Then don't forget units, so you would say meters squared. Now, surface area. Very good. That's the equation. Now, remember, we already know the first part because 36 pi is the lateral area, which is that first part, right? So you could say 36 pi plus 2 pi, what's r? 3 squared. So it's really 36 pi plus 3 squared we know is 9. And don't forget to also times it by 2. So 18 pi. Sure, yeah, you can rearrange the numbers. It doesn't matter. So basically what I say is ignore the pi and do everything else. Okay? So 3 squared is 9. 9 times 2 is 18. What's 36 and 18? 54. Don't forget to keep what with it? Pi, and then meters squared. So there's my surface area. So the last thing we need to find is our volume, which is pi r squared h. So pi, 3 squared, not 18, 9. 3 squared is 9. So 9 times 6 is 54. Don't forget to put the pi with it. And then units, meters cubed. There are many, many, many times where your surface area and your volume will be the same. And that is okay when you're talking about cylinders. All right, let's do our last one here, and then I will give you guys a chance to work on your homework. See, don't you like cylinders a lot better? Yeah. And what you can also do with your calculator is you could just type it in, just ignore the pi. 2 times 3 times 6 equals 36. 36 plus 2 times 3 squared is 54. You don't have to show all the work if you don't want to. I would like to see what you plug in so that way I can give you partial credit in case you make a mistake. Because what are we given in this problem? So radius is, and what's my height? 2. So we're going to use the numbers 5 and 2 throughout this to figure out our answers. So lateral area is 2 pi 5 2. Just plug them in, right? 2 pi RH. So 2 times 5 times 2 is 20 pi. And units? Very good. With our surface area, remember it's the lateral area plus 2 pi r squared. So you could just pull this number down. 20 pi plus 2 pi. R is 5. That's right. 5 squared is 25. Times 2 is 50 pi. 20 and 50 make 70 pi centimeters squared. 5 squared is 25, and then times the 2. Yeah, don't forget to times the 2. That's a big mistake that people usually make as they square the number, but forget to multiply by 2. And volume, pi r squared times h, which is 2. So what is 5 squared times 2? 50 pi units, centimeters cubed. And a lot of times you will see too with surface area and volume that volume is smaller than surface area, and that is okay as well. A lot of people think volume should always be bigger, but it's usually surface area that is. It takes more to paint around than it does to fill it up. Different measurements though. All right, your homework, just making sure that was it. Yep. Your homework is this worksheet, and I know that it looks like a lot because we have done a lot today. So I'm going to say that this is due any time tomorrow, but we will go over homework questions tomorrow at the beginning of class like we normally do. The problems on the front are your ones that we went over where you need to find lateral area, surface area, and volume. And then on the back is like the ones that we did at the beginning of class where you're talking about the polyhedrons. Sorry, the print's kind of small on the back, but you might want to start on the back and then move to the front, or whichever way you want to do it, whichever way you're most comfortable. But again, due tomorrow.